Good evening, Eric Monroe here. I'm going to be talking about how I pwned the LOHAS smart bulb. So it was a multi-step process. I started out by using esptool.py to, well, no, that wasn't how I started out. The first thing I did with the project was I broke open the light bulb and I accessed the test points that the manufacturer left on top, the gold-plated test points. So a lot of the people who have pwned this smart bulb used the GPIO 0 pin, the RX to TX, the ground, the 3.3 volt, and the reset pin. However, I only went for 5 of them, mostly because I didn't want to solder the reset pin because it's in the middle of a bunch of electronics. The reset pin is only if you want automated resetting of the ESP 8266 when you finish uploading a sketch. I could just pull out the GPIO pin and reset it myself. So the first thing I did was I broke out those plates. After I broke out the plates, that meant I could force the ESP into one of the 2 boot modes I needed it to be in, either in normal boot mode or the UART download / boot mode. So the first thing I wanted to do was I wanted to connect to it with the Raspberry Pi and use esptool to dump the flash memory. It was dumped to a bin file. I ran esptool in a virtual environment, and in plain text there were tons of there was the device ID and the private key that it uses to communicate with the server for control. So after I exposed that vulnerability, I decided to upload my own firmware to the chip in order to finish pwning it. So the process for that was I went ahead and I used UART, a USB port to UART converter to a breadboard, and yeah, to that breadboard right there. And with that, I was able to use a Arduino board manager add-on that somebody went ahead and made, and by pulling GPIO 0 to ground when I power on the light bulb, it's in boot mode and I can upload any sketch I want. So I found drivers to the it's some LED driver chip, the MY9231, which is the LED driver on the smart bulb, and I was able to load my own firmware onto it and make the LED driver do a rainbow color pattern. And I also have the chip connecting to the Wi-Fi as well off this sketch, so opportunities to expand this project further include like being able to load an MQTT client onto the chip, and I can just control the smart bulb off my own MQTT client from the Raspberry Pi. So I'm going to go ahead and plug the smart bulb in just to show off how I went about pwning it, which was just loading my own software, breaking out the chip, loading my own software, and making it do something that it was not programmed to do in this way. I'm not going to look at straight at it, but it should start any second now. That one might be dead. There we go. So as you can see, I just have the LED driver cycling through the entire range. I believe channels 0, 1, and 2 are the channels that that particular chip is using for the red, green, and blue channels. I'm not utilizing any of the other channels. But again, I can probably load this onto an MQTT client and control it remotely if I wanted to expand the project further. Anyways, that is it for my pwning of the LOHAS smart bulb.